Okay, students, this is question number 12. We've been given a curve and a line. We are asked to find the point of intersection of the line and the curve. Now this graph is of this form, so you have the curve going like this, and then the line is hitting the curve. Probably it is not on the x-axis. Maybe I will draw it a little bit more better. So the line is actually hitting the curve at this end and over here. So this is C and this is B. This is the x-axis, this is the y-axis. Now we have been given a point A as 4, 0, and of course the curve is given and the line is given. The line is 3, negative x. So what we are going to do is we are going to take this as 1, we are going to take this as 2, and then we will equating 1 and 2 we get. So that would be 4 times x raised to the power 1 over 2 negative 2x is equal to 3 negative x. I'm going to rewrite this as 4 times x raised to the power 1 over 2 negative 2x positive x negative 3 is equal to 0. You add these two together, you get 4 times x raised to the power 1 over 2 negative x negative 3 is equal to 0. Now I'm going to let x raised to the power of 1 over 2 be equal to, say, some t squared. And why do I do that? Because I want a quadratic system here for enabling me to solve and find the value of the point of intersection. Now if I were to square both sides, this would become the 1 over 2 and 2 gets cancelled. I get x is equal to, I need to square this also, so this will become t raised to the power of 4. So this is going to be 4 times t squared negative t raised to the power of 4 negative 3 is equal to 0. I multiply by negative 1 throughout, so this will become t raised to the power of 4 negative 4 times t squared positive 3 is equal to 0. Now I'm going to take t squared be equal to some u. So this would become u squared negative 4 times u positive 3 is equal to 0. Now I'm going to use a quadratic system to solve this. So if I were to use a quadratic system to solve this, I would have 4 plus or minus the root of 4 squared 16 negative 4 times a times c. So this is going to be 4 plus or minus root of 16 negative 12 divided by 2, which is 4 plus or minus the root of 4 divided by 2. So u will be 4 plus 2 divided by 2, or u will be 4 negative 2 divided by 2. This would give you u to be equal to 6 over 2, that's 3, and u will be 2 over 2, that's equal to 1. But my u is actually t squared, right? So t squared is equal to 3 and t squared is equal to 1. So from here you get t is equal to plus or minus the root of 3 and t is equal to plus or minus 1. But my t squared, or I would say t raised to the power of 4, right? So let me just take it like this. My t squared is actually equal to x raised to the power of 1 over 2, right? This is the initial substitution we took. So in that case we can just settle with this. You see that we already have t squared is equal to x raised to the power 1 over 2. So this, from here I'm going to utilize this. I don't need this. So t squared is equal to 3, and that would mean root of x is equal to 3. So I square both sides. So I would get x is equal to 9 at one spot, and in this case from here x raised to the power of 1 over 2 is equal to 1. I square both sides, I get x is equal to 1. Right, so x is equal to 9 and x is equal to 1. So now go back to the curve. I'll utilize this one. X is equal to 9. When x is equal to 9, y will be 3 negative 9. Y is going to be equal to negative 6. And then when x is equal to 1, y is equal to 3 negative 1, which is equal to 2. So the points, so I have a point x is equal to 9 at one point, and y is equal to negative 6 is the other, and the next one is x is equal to 1 is one point, and y is equal to 2 is the other point. Okay, so 2 points are actually obtained. So from the graph, clearly we can see that this is my point B, this is my point C. So why do I say this is my point C? Because you see this is on the negative end, C is on the negative end corresponding to the y-axis. So we have got the two coordinates that is required in the question. Now the next part is show B is the stationary point. So for that we differentiate with respect to x. So it's going to be dy over dx is equal to 4 times of 1 over 2 times x raised to the power of 1 over 2 negative 1. Negative differentiation of 2x is going to be 2. 2 divides 4 2 times, so 2 times x raised to the power of 1 over 2 negative 1, that's negative 1 over 2 negative 2. This is dy over dx. Now for stationary point, what we have to do is we have to take dy over dx is equal to 0. So this means 2 times x raised to the power of negative 1 over 2 will, I just take it as negative 2 is equal to 0. So this means 2 times x raised to the power of negative 1 over 2 be equal to 2. 2 gets cancelled, you got x raised to the power of negative 1 over 2 is equal to 1. I can rewrite this as 1 over x raised to the power of 1 over 2 is equal to 1. This can be further rewritten as 1 over the root of x is equal to 1. So move this to the other side. This means 1 is equal to root of x. This in turn would mean root of x is equal to 1. So you square both sides. This will give you x is equal to 1. So which means B is the stationary point. So this means B is the stationary point. So that completes this question, students. Thank you.